we see the definitions of permutation and combination, we learn a simple principle, basic principles which are required for understanding these two things. First one is addition principle. Addition principle. Let us consider an event can occur, an event, let us say E, can occur in M ways, and another event F independent of E can occur in N ways. Then the event E or F, I am emphasizing the word or, E or F can occur in M plus N ways. So this is called addition principle. To understand the principle, we take a small example. Let us say there are 5 female teachers and 4 male teachers for the post of a teacher in a school. The question: in how many ways a teacher is selected? So if you want to select only female teacher, you can do so in any one of the 5 ways, because 5 female teachers are available for the post, they applied for the post. Similarly, 4 male teachers applied for the same post of teacher. The question in how many ways a teacher is selected means there is no condition that who has to be selected. You can select either a male or a female. That means if E stands for a female and F stands for a male teacher, you can choose either E or F, where females are 5 in number, males are 4 in number. When you want to choose either male or female, then I can write E or F can occur means we can choose, can occur in M plus N ways, means either female or male can be chosen in 5 plus 4, that is 9 different ways are possible. So whenever we say an event E or F, we go with the addition. Similarly, we have one more principle that is called multiplication. Multiplication principle. We see what this principle is. Let us say an event E can occur in M ways. Another event F, which is independent of E, can occur in n ways. Then the event E and F, I am emphasizing the word and, can occur in m into n ways. So here also we can understand the principle in a better way by an example. Let us consider there are 5 shirts, 3 pants and 2 ties. In how many ways a pant, a shirt, a tie can be chosen? So here we are not choosing any one, but we are choosing each one pant, one shirt and one tie. Therefore, the number of ways of choosing one pant, if you want to choose one pant, you can do so in 5 ways. If you want to choose a pant, you can do so in 3 ways. If you want to choose a tie, we can do so in 2 ways. As we are choosing pant and shirt and tie, we are multiplying them. We are not adding, we are just multiplying, because we want all the one, each one from shirt, pant and tie, unlike in the previous case where we can choose either a male or female, not both male and female. Therefore here the number of ways would be 30. So 30 different ways of choosing a pant, a shirt and a tie. We consider, before we take the definitions of permutation and combination, we consider here a simple example. Let us say there are 3 objects A, B, C. Now the question, we have to choose any 2 of them. That means AB, AC, BC. I am choosing any 2 of them. So when I say AB, whether I say AB or BA, it represents the same group. That means when order or arrangement is not considered, then we say it is selection of the people. In this case, we are selecting 2 people at a time. So there are 3 possible ways. Whenever I use a word like selection, it is a combination, meaning we do not consider the order. Whether you say AB or BA, it represents same group. So whenever we say no order is given important, we consider it as a combination of the things. So therefore it is a selection. Now you consider the same 3 groups, AB, AC, BC. Now the group AB can be arranged in arrangement, I say AB or BA. 2 arrangements are possible. Similarly, AC, CA, BC, CB. Whenever I consider arrangement, means whenever order is given importance. It is nothing but permutation. We say it is permutation, means we consider the order into consideration. Now I take a small example to distinguish these two words, because most of the students, they find difficulty in applying combination and permutation to the question. Let us consider there are 3 points A, B, C. Now how many lines I write the question, how many lines can be formed, that is the question. So to form a line we need 2 points. Let us say AB is a line. When I say AB is a line, BA also represents same line. That means whether you consider AB or BA, we are getting same line. Similarly, BC or CB, AC or CA. So in this case, order need not to be taken into consideration, because in the question it is not said whether to consider permutation or combination. Still, looking at the question, we can say here order is not given importance. Therefore, we say we apply in this case combination of the points. Combination of points are taken. Likewise, I take another example for permutation. Let us consider 3 numbers, 1, 2, 3. How many 2-digit numbers can be formed? That is the question. When I say 2-digit numbers can be formed, means we shall do practically 1 2, 1 3, 2 3. But 1 2 can also be written as 2 1. Now when you change here, it is not represent the same number, it represents 2 different numbers, 3 1, 3 2 similarly. So in the previous case, whether you consider AB or BA, it is representing the same line. Whereas here, taking different arrangements of numbers, it gives different values. Therefore, in this case, even though it is not said in the question whether permutation or combination to be considered, we can clearly go with the permutation of objects. Permutation of objects, because different arrangements will give you different numbers. So this is the basic difference between the permutation and combination. Now we shall see the definition of these two words. After learning the permutation and different combinations difference, we can take the actual definitions of permutations and combination. First, what do you mean by a permutation? We learned, now we see the definition. Suppose permutation. Suppose there are n objects. Arrangement of a time is called permutation of n objects taking or at a time. It is denoted by NPR. So NPR is n factorial by n minus or factorial. So here when you take the permutation of the objects, there is no repetition of the objects in this case. So NPR equal to n factorial by n minus or factorial. Suppose if R equivalent to n, that means if you take all the objects and start arranging, then it is called as linear permutation. So therefore I can write here, so linear permutation is arrangement of n objects taking all at a time in a row. Therefore npn equivalent to n factorial n minus n factorial means n factorial by 0 factorial into equivalent to n factorial, where 0 factorial is 1. Therefore when you arrange all the objects at a time, then your permutations is number of permutations, also it is called as number of arrangements, is in factorial. Now we take one more here permutation, circular permutation, or okay, before that I take a permutation of like objects. Permutation of like objects. Suppose there are n objects, P of which are alike, Q of which are alike of another type, and are alike of third type. Then number of permutations is, if all are different, number of permutations is n factorial, but out of which some are alike, let us say P and Q are alike of another type, or are alike of third type. Therefore now the number of permutations reduced to by phi factorial, Q factorial or factorial. Let us take example like arrangement. So above word can be arranged here, arrangement, or I can say permutation equivalent to, totally we have 6, 9, 11 factorial. So if all are different, your answer is 11 factorial. But out of which a or twin number, they are alike of one type, 2 factorial, or also 2 factorial, n is 2 factorial, e is 2 factorial. So therefore the number of arrangements would be equivalent to 11 factorial by 2 factorial, 2 factorial, 2 factorial. So again, going to the next definition, we have seen permutation of like objects. Another one is circular permutation. Suppose there are n objects, arrangement of these objects around a circle is called circular permutation. So here we can put it like this: when you arrange them in a circle, we want a reference point to arrange other objects with respect to which we consider, let us say, one objects, and the remaining n minus 1 are arranged with respect to the considered object. Therefore, in this case, the number of permutations equivalent to n minus 1 factorial. Sometimes the objects are similar. If objects are alike, or I can say similar, I can write here similar. Now the number of permutation when you arrange them in a circle is n minus 1 factorial by 2. In the above case, we considered all objects are different, therefore we got n minus 1 factorial. In this case, if they are similar, then whether you consider clockwise direction or anti-clockwise direction, it gives same arrangement. Therefore, it is reduced to half. Hence, the number of permutation is n minus 1 factorial by 2. This is circular permutation. Now we shall see the definition of combination. Combination. Suppose there are n objects, selection of or of these objects at a time is called combination of n objects taking or at a time. It is denoted by NCR. Therefore, NCR equivalent to n factorial by r factorial n minus r factorial. This can be rewritten as n factorial by n minus r factorial. So NCR equivalent to 1 by r factorial. If you recall the definition of permutation, n factorial by n minus r factorial is nothing but npr. So therefore I can write npr equivalent to r factorial times ncr. Hence npr is always much bigger than ncr. So this is about combination. See the question. We shall find n here. Given np4 equivalent to 3024. So we know that np4 equivalent to n factorial by n minus 4 factorial. We can expand n into n minus 1, n minus 2, n minus 3, n minus 4 factorial by n minus 4 factorial. So 3024. Now we shall cancel the terms. Therefore n into n minus 1, n minus 2, n minus 3 equivalent to 3024. Here we shall take n a proper value so that the product of 4 consecutive numbers is equivalent to 3024. So here if you take n equivalent to 9, then 9 into 8 into 7 into 6 equivalent to 3024. Hence n equivalent to 9 is the required answer. Where NC3 is given as 120. Again we have to find the value of n. So we know NC3 is n factorial by 3 factorial into n minus 3 factorial equivalent to 120. Now again n minus 1, n minus 2, n minus 3 factorial by 3 factorial into n minus 3 factorial equivalent to 120. So 3 factorial is 6, cross multiplying we get 720. Cancelling n minus 3 factorial, we get n minus 1, n minus 2 equivalent to 720. Here you take orally n equivalent to 10. Then 10, 9, 8 equivalent to 720 is verified. Therefore n equivalent to 10 is required answer. So see the question. NC7 is equivalent to NC8. We know that NCR equivalent to NCn minus R. So comparing with the given question, therefore R equivalent to 7 and n minus R equivalent to 8. Hence n minus R equivalent to 8 and R is 7. Therefore n equivalent to 15 is the required answer. Hence n is the answer. N equivalent to 15. N factorial by n minus 8 factorial equivalent to 336 NP5. by expanding n factorial as n minus 1, n minus 2, n minus 7, n minus 8 factorial by n minus 8 factorial equivalent to 336. Again by expanding n minus 1, n minus 4, n minus 5 factorial by n minus 5 factorial. By cancellation of the terms on both sides, we get n minus 1, n minus 2, n minus 7 equivalent to 336, n minus 1, n minus 2, n minus 4. Again, looking at the terms on both sides of equality, again we can simplify, then it reduces to n minus 5, n minus 6, n minus 7 equivalent to 336. So we shall consider some appropriate value for n so that the product of three consecutive numbers shall equivalent to 336. So here n equivalent to 13 substitute here, then n minus 5, n minus 6, n minus 5 is equivalent to 13 minus 5, 13 minus 6, 13 minus 7. Therefore 13 minus 5 is 8, 7, 6 equivalent to 13. Hence n equivalent to 13 is the required answer. So 15 factorial by 15 minus or minus 1 factorial is to 14 factorial by 14 minus or minus 1 factorial equivalent to 15 is to 7. Now 50 factorial by 15 minus or plus 1 factorial, 14 factorial by 14 minus or plus 1 factorial equivalent to 15 is to 7. So therefore this simplifying them, 16 minus or factorial into taking reciprocal 15 minus or factorial by 14 factorial equal 15 by 7. Again 15 into 14 factorial by 16 minus or factorial, 15 minus or factorial by 14 factorial equal to 15 by 7. By cancelling we get 15 minus factorial by 16 minus or factorial equivalent to 1 by 7. Taking the value for all as 9, we get 15 minus 9 is 6 factorial by 16 minus 9, 7 factorial equal to 1 by 7. Therefore or equivalent to 9 is required answer. consider the permutation of the players. So therefore, out of 45, every two player post one card to each other. So therefore, 45 P2 equivalent to 45 into 44. So that is equivalent to, there are 45 basketball players. Everyone posts a greeting card to all other players. Therefore here we have to consider the permutation of the players. So therefore, out of 45, every two player post one card to each other. So therefore, 45 P2 equivalent to 45 into 44. So that is equivalent to 190. The given word, that is gate forum, which contains totally 9 letters. So number of letters are 9. Letters of the word given are 9. We have to find 5-letter word which should begin with A. So therefore, first I consider 5 blanks to fill with 5 letters. Since the first letter always should A, I fill with A, and the remaining 4 letters have to be filled with remaining 8 letters. Therefore, first blank can be filled with any one of the 8 letters, second with 7, third with 6, last with 5. Therefore, the number of words which begin with A are 8 into 7 into 6 into 5, which is equivalent to 1680. Likewise, I consider another 5 spaces to fill 5 letters. So it should end in R. Therefore, I am filling the last letter R, and remaining 4 letters should be filled with remaining 8 letters. Therefore, this can be filled in 8, other one 7, 6, 5. Again, the number of words equivalent to 8 into 7 into 6 into 5, which is equivalent to again 8, 16, 80. The last one we have to find again 5-letter word which should begin with A, end in R. I fill these 2 spaces with A and R, so that in between we can fill with the remaining letters. Out of 9, 2 letters have been filled, so still 7 are there. These 7 can be filled here, any one of the 7 letters, and remaining any one of the 6, and remaining any one of the 5. Therefore, the number of words in this case would be, that means the number of words that begin with A or end in R would be 7 into 6 into 5, that is equivalent to 6 into 5, 30, 30 into 7, 210. So therefore totally 210 words are there here. The word gate forum. Gate forum. So we have to find all the possible words in which at least one letter is repeated. But in order to find this answer, first we have to find how many words are possible, that means 4 letters words. So that can be calculated here, number of 4-letter words equivalent to 9p4. This will give you all possible words, that means 4-letter words in which no letter is repeated. Suppose if you want to find at least 1-letter word, let us consider 4 blanks. Since the repetition is allowed. First one can be filled with any one of the 9 letters. As repetition is allowed, second one can be filled with 9, third with 9, fourth with 9. Therefore, the number of words with repetition equivalent to 9 raised to 4. But we need only the words which are repeated. Therefore, at least one letter is repeated. Therefore, the number of words at least one letter is repeated equivalent to 9 raised to 4. Actually, this 9 raised to 4 contains all possible words wherein you find 1 letter repetition, 2 letter repetition, 3 letter, 4 letter and no repetition. From this we subtract the number of words which are not repeated. Therefore, the remaining words will give you the words in which at least one letter is repeated. Hence, your answer in this case is answer is 9 raised to 4 minus 9p. 4. You are given a word danger. So this contains totally 2 vowels, that is A and E. The question here, we have to find all possible words so that no vowel occupies odd places. It is a 6-letter word. Therefore, it contains 3 odd places, 3 even places. But the number of vowels given in the word, number of vowels in the given word are A and E. Therefore, these 2 letters can occupy any of the 3 places. Therefore, the number of ways of arranging these 2 letters equivalent to 3p2, that is equivalent to 3 into 2, 6, and remaining 4 consonants can be arranged in remaining 4 places. Therefore, these consonants can be arranged in 4 factorial ways. Hence, the required answer is 4 factorial into 6, that is 24 into 6 equivalent to 144. Hence, your answer is C, that is 140. We are given totally 7 boys and 6 girls. We have to arrange them in a row. The first question, it is given all the boys have to be seated together. Therefore, we consider them as one unit. And 6 girls are 6 different people. So totally we have 7 people. Hence, the number of ways of arranging them, that is 7 boys and 6 girls, can be arranged totally 7 factorial. But these 7 boys which can be arranged among themselves into another 7 factorial. Therefore, it should be 7 factorial whole square. That is for the first question. Coming to the second one, no two girls are seated together means for every girl on either side we have to make boys to sit. Therefore, first what I do, I arrange all the 7 boys like this, a place in between for a girl. So therefore, totally we can arrange 7 boys in this way. 7 boys, and in between you find a place for the girl, but here also we can make the girls sit. Hence totally we have 1 2 3 4 5 6 7 8 places for 6 girls. Therefore the number of ways of arranging 6 girls in 8 places is 8p6, and these 7 boys can also be arranged among themselves into 7 factorial ways. Hence the answer is D. We are given a word Pascal which contains 2 vowels, that is A and A. The question here, we have to arrange all the 6 letters of the word so that the relative position of vowels and consonants are not disturbed. Means vowels to be placed in the place of vowels and consonants are to be placed in the place of any other consonant. That means a consonant can take only the position of any other consonant, and vowel can take the position of any other vowel. So therefore the number of consonants are 4. These consonants can be arranged in 4 factorial. Hence number of arrangements for consonants equivalent to 4 factorial, meaning that means 4 factorial in 4 places, that is 4 factorial, and vowels can be arranged in the place of vowels. Therefore we can write here means A can be interchanged with A, so therefore I can write number of arrangements for vowels equivalent to 2 factorial by 2 factorial, because A is repeated, hence we write by 2 factorial. Therefore the number of arrangements equivalent to 4 factorial into 2 factorial by 2 factorial, that is we get 24. Hence your answer is C. We are given totally 6 digits. So the first question we have to find how many 5-digit numbers can be formed with the help of 6 digits. So therefore the number of numbers that can be formed equivalent to 6p5, that is 6 into 4 into 3 into 2 into just 6 5 4 3 2, so that is equivalent to 720. And among them how many are divisible by 2? In order to find here, first we shall find 5 places for 5 digits, and all the numbers that are formed here should be divisible by 2. Therefore, we have to fill the digit in the unit place which is always divisible by 2. Hence, we get all the numbers which are divisible by 2. Hence, the first place can be filled with any one of the number that is divisible by 2, that is 6 and 8. Hence, there are two ways of filling them. It is not the digit 2, it is two ways of filling. The first, that is either 6 or 8. Now, once we filled, still 5 letters are left over. We can fill any one of the 5, 4, 3, 2. Therefore, the number of numbers which are divisible by 2 equivalent to 2 into 3 into 4 into 5 into 2, that is equivalent to 240. Similarly, we have to find 5 digit letters which are divisible by 5. Again, like in the previous case, we have to fill the digit in the unit place which is divisible by 5, which is possible only when you write 5 among the given digits. That is only one way of, and remaining 5 letters can be filled in the remaining 4 places, that is any one of the 5 in the remaining 5, and 4, 3, 2. Therefore, the number of numbers which are divisible by 5 equivalent to 2 into 3 into 4 into 5 into 1, that is nothing but 5 factorial, that is 120. Hence, your answer is A. We have to find 4 digit numbers using the given digit where repetition is not allowed. So therefore, first I consider 4 places for 4 digits. So among the digits given, there is 0, which cannot be placed in units, tens, 100, 1000 places. If you place in thousands, it becomes a 3-digit number. Therefore, the 1000 place can be filled with any one of the 5 remaining digits. Therefore, here 5 ways of filling the 1000th place. 100th place can be filled including 0. There are 5. So therefore, any one of the 5 here. 10th place 4 ways, and this is 3 ways. Therefore, the number of 4 digit numbers equivalent to 5 into 5 into 4 into 3, that is 25, 100, 300. So therefore 300 is the required answer, that is D. We are given 0, 1, 2, 3, 4, 5, totally 6 digits. We have to find the number of numbers which are greater than 2000. Even though it is not mentioned in the question how many digits, we shall consider 4 digit numbers which are greater than 2000. So in order to find numbers greater than 2000, the digit in the 1000th place cannot be 0 or 1. So therefore, any one of 2, 3, 4, 5, that is any one of the 4 numbers can be filled in. Again, in 100th place, any one of the 6, once you fill, we have still 5 numbers, any one of the 5 numbers can be filled in 10th, 100th place. Again, any one of the remaining 4 in 10th. Again, 3 ways of filling. Unit, digit, place. Therefore, the number of numbers greater than 2000 equivalent to 4 into 5 into 4 into 3. So the answer is 20, 80, 240. Hence your answer is B, that is 240. They are given totally 5 boys and 6 girls who have to be arranged along a circular table. In the first case, all the girls have to be seated together. Means 6 girls are taken as 1 and the remaining 5 boys as 5. So all these 5 boys and 6 girls as 1, that is total 6 people can be arranged around a circular table in number of arrangements equivalent to 6 minus 1, that is when you arrange along a circular table 6 subtract 1, therefore 5 factorial. And as girls are together, these 6 girls can be arranged among themselves into 6 factorial ways. Hence the total number of arrangements would be 86,400. In the second case, no 2 boys have to be seated together. That means on either side of a boy we should have a girl. So in this case, first we arrange the girls in a circular table, that is 6 girls are arranged in between a place we have to have for a boy. So these 6 girls can be arranged around a circular table in 5 factorial ways, and there are 6 places for boys who have to be seated 6. So therefore I can write here number of arrangements would be 6 girls can be arranged in 5 factorial ways and 5 boys out of 6 places, therefore 6p5. Hence it is equivalent to 5 factorial into 6 factorial, that is 6, 5, 4, 3, 2. That is equivalent to 5 factorial into 6 factorial, that is again 86,400. Hence your answer could be C. Political leaders given is 20. When you arrange all these political leaders around a circular table, then the number of arrangements would be equivalent to 20 minus 1, that is 19 factorial. Hence your answer would be D. We are given the number of colored beads equivalent to 25. If they are same color, then the number of arrangements would be 24 factorial by 2. Assuming that here all beads are similar color, therefore whether clockwise or anti-clockwise, it cannot 24. So therefore the number of arrangements will reduce to 24 factorial by we are given digits 1, 3, 4, 5, 6, that is 5 digits, and we have to find all 4 digit numbers sum. So this can be solved by using the formula n minus 1 p or minus 1 equivalent to sum of digits into 1 1 1 or times. So this will give you sum of all 4 digits without any repetition. So hence I can write the required sum would be where n equivalent to 5, therefore 5 minus 1 4 p 3. Sum of the digits is 1 plus 3 plus 4 5 plus 6, and since we want only 4 digits we can write 4 times. So simplifying, I get here 10 19. So simplifying, your answer would be 506616, that means 50,000. So your answer is C. Given 5 digits, that is 0 1 2 3 4, that means n equivalent to 5, but we have to find sum of all 4 digits, that means R should be 4. As the given digits contains 0, when you apply the formula sum equivalent to n minus 1 p or minus 1 sum of digits into 1 1 1 or times, this will give sum of 4 digits, no doubt, but among them some digits begin with 0, which are actually 3 digit number, because here when I take n equivalent to 5, 0 is also considered as 1 digit. First let us find the sum here. 5 minus 1 p 4 minus 1, sum of the digits 0 plus 1 plus 2 plus 3 plus 4 1 1 1 1 4 times, therefore that is 4 p 3 into, adding the sum we get 10 1 1 1 1. So this should be equivalent. Okay. So this can be calculated as 4 into 3 into 2 into 1 into 10 into 1 1 1 1. So this sum will give you sum of all 4 digit numbers, which also contain some digits that begin with 0. So simplifying here further, so 24 into 10 into 1 1 1 1. Let us keep this sum, later we can calculate. Again we shall find out the sum considering only 1 2 3 4, because I want to find out sum of all 3 digit numbers. So therefore the sum would be equivalent to n minus 1 p or minus 1 sum of digits 1 1 3 times. So therefore here 3 p 2, sum of the digits is 1 plus 2 plus 3 plus 4, So this would be equivalent to 3 into 2, this is 10, so therefore the sum would be 60 into, so this sum will give you sum of all 4 digits which begin with 0, which are included in the previous sum. So therefore the required sum would be equivalent to, because the first one will give you sum of all 4 digits which also contains some digits begin with 0. Therefore simplifying the question above two sums, subtracting the second sum which are 3 digit numbers, let us say, which begin with 3 digit numbers which do not begin with 0. So therefore if we just calculate, the required sum would be equivalent to, so your answer is B. Okay. We have to find how many parallelograms can be formed out of 20 parallel lines which are intersect with another 25 parallel lines. Now the number of parallels can be formed, number of parallelograms equivalent to, so out of 20 lines we choose any two, so this will give you all possible two lines which are intersecting with another all possible two lines out of given 25 parallel lines. Therefore the number of parallelograms can be equivalent to 25C2 and into 25C2, that is answer given 10 people. But we have to select only 6 people of them, but out of 10 one particular person should not be included. You just remove that person, so still 9 people are there. So out of these 9 people we select 6 which do not contain a particular person because we already removed. Therefore number of ways of selecting 6 people would be equivalent to, because we have just 9, out of them we have to select only 6, hence your answer is C. Totally 7 men and women are 6. We have to select a committee of 10 members which includes at least 7 men, means it can be at least 4 men, so therefore it can be 4, 5, 6, at the most 7 men can be included in the committee. Let us say first we include 4 men, so 7 are given, out of them we select only 4, but we need totally 10 people, so therefore remaining 6 people can be selected from women. Therefore 6C6, that is equivalent to 7C3, because NC are equivalent to NC n minus R, into 6C6 means just 1, that is equivalent to 7 into 6 into 5 by 3 into 2 into 1. By simplifying we have 35. So there are 35 ways of selecting 10 people which contains at least 7 men and remaining are women. And in the second case we take 5 men and remaining 5 we choose from women. So therefore we can write again 7C2, because NC are equivalent to NC n minus R, again 6C1, so that is equivalent to 7 into 6 by 2 into 1, again if you take here just 6, by cancelling here, we get 21 into, so that is not 42 into 3. Therefore this is 6 and 12, 126 ways of choosing a committee of 10 people which contains 5 men and remaining are 5 women. Again, in the next case, we can choose 6 men and the remaining 4 people out of 6 women. So therefore that should be equivalent to 7C1, again 6C2, equivalent to 7. This is 6 into 5 by 2 into 1. Again simplifying, we get here 7 into 3 into 5. Therefore that is equivalent to 105. That means 105 ways of selecting a committee of 10 people containing 6 men and 4 women. Again, in the next case, we can choose all 7 men and the remaining 3 women from 6 women. So therefore that is equivalent to 1 into 6 into 5 into 4 by 3 into 2 into 1. By simplifying, we get here 20. So therefore the total, the number of ways of selecting a committee of 10 people with at least 4 men equivalent to 35 plus 126 plus 105 plus 20, that is equivalent to 286. Hence your answer is D. Totally 11 persons to be seated around a circular table. The question here, how many ways we can select 2 persons who are not seated adjacent to each other. So first let us seat all the 11 persons around a circular table, P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11. So if you select 2 people among them, number of ways of selecting 2 persons equivalent to 11 C2, that is equivalent to 10, 11 into okay, so 11 into 10 by 2 into 1. So therefore 55 ways of choosing 2 people. But first we have the possible adjacent people, or I can say we can find here is, let us say P1, P2, P2, P3, P3, P4. Likewise, we can find totally P11, P1. So which are 11 in number. So these, what I can say, P1, P2, P2, P3, they are adjacent. If you subtract from the above, then we get number of ways of selecting 2 persons, selecting 2 persons who are adjacent each other equivalent to 55 minus 11, that is 44. So your answer is 16 points, and out of them collinear or 5, means if the points are linear, they lie on the same line. The question, how many triangles can be formed out of these 16 points? To form a triangle, we need 3 points. Therefore, the number of triangles can be formed equivalent to 16C3. But there are 5 points which are collinear. Therefore, triangles formed out of these 5 collinear points are not triangles. Hence, we can find here the required number of triangles equivalent to 16C3 minus 5C3. So that if you work out, the answer would be equivalent to 550. That is 16, 15, 14 by 3 into t into 1 minus 5, 4, 3 by 3 into 2 into 1. So hence your number of triangles will be equivalent to 550. That is answer A, given 20 points which are not collinear. So all the points cannot be taken on the same lines. Now the question, how many distinct lines can be formed? To form a line, we need 2 lines, 2 points. Therefore, the number of lines equivalent to 20C2. That is 20 to 19 by 1. So therefore, the answer should be 190. That is, answer is, there are 40 students. We have to find how many handshakes or takes place between them if each student shake his hands with other. So when a student handshakes with other, it is as well as saying other student is also handshaking with this boy. Therefore, here we have to consider combination, because order is not considered. Whether a student A handshakes with B or B handshakes with A makes no difference. So therefore, I can write here the number of handshakes that takes place among 40 students is 40C2. That is equivalent to 40 into 39 by 2 into 1, that is 20, equivalent to 780 distinct 4-digit numbers which are greater than 5000, and the digits given here are 3, 2 numbers are there, 5, 3 in number, 8, 4 in number. So as we have to find 4-digit number, first I take 4 blanks which are greater than 5. That means the digit in thousands place cannot be 3. So it should be either 5 or 8, that is 2 ways. Again, 100th place, any either 3, 5 or 8 can be written, that is in 3 ways. Again in 10th place in 3 ways, any one of the 3, that is either 3, 5 or 8. Again in the unit place either 3, 5 or 8, that means in 3 ways. Hence the total number of numbers greater than 5000 greater than 5000 equivalent to 2 into 3 into 3 into 3, that is 54. But when I take greater than 5000, we also consider numbers like 5, 3, 3, 3 and 8, 3, 3, 3. Again 8, 5, 5, 5, 5. All these numbers are greater than 5000, which are considered, but above 3 numbers are not possible because we have only 3 in 2 numbers, hence first number is impossible. Likewise second number is also impossible. Third number 5 fours is not possible because we have only 5s or 3 in number. In subtracting above 3 numbers, the required numbers are 54 minus 3, that is 51. Hence your answer is B. Log having 4 rings and each ring can have 10 digits from 0 to 9. Therefore, the number of ways of filling all the 4 digits here is: first can be filled with any one of the 10 digits, second also 10, third also 10, fourth also 10. So therefore the number of possible attempts would be equivalent to 10,000, but out of 10,000 only one is successful and the remaining are unsuccessful. So hence the number of unsuccessful attempts would be equivalent to 10,000 minus 1, that is 9,999. That is answer A. We have 6 different books, each 7 copies. Therefore the total number of books would be equivalent to 6 into 7, 42. So these books can be arranged in 42 factorial, but each book is of 7 copies each. Therefore the number of arrangements means arranging these books in a shelf is 42 factorial by each one repeats 7, therefore 7 factorial. Likewise 6 different books raised to 6. Therefore your answer is D. The question: we are given 6 digits, 1, 1, 2, 2, 3, 3. We have to find 6 digit numbers, but here each digit repeats twice. So therefore the number of 6 digit numbers, if there is no repetition, it is 6 factorial if all the digits are different, but each digit repeats twice, therefore divided by 2 factorial, 2 factorial, 2 factorial, equivalent to 720 is the value of 6 factorial by 2, 2, 2. So therefore 720 by 8 by simplifying you get 90. So therefore